Intermediate Algebra, Section 5.7, Factoring, a General Strategy. When we're factoring, you always want to factor out a greatest common factor if possible. Once the greatest common factor has been factored out, count the number of terms. If it's a two-term, try factoring by a difference of squares. If that doesn't work, look for factoring for a sum or difference of cubes. If it's a three-term, it's good to do a quick check to determine whether it's a perfect square trinomial. If not, then we'll factor using FOIL or grouping method. 4 or more terms, try factoring by grouping and factoring out common binomial factors. Alternatively, we can try grouping into differences of squares, one of which is a perfect square trinomial. But we always want to factor completely, and here's some more examples. Greatest common factor is 1 between all three terms. Looking first, is this a perfect square trinomial? The first term is a perfect square, but 35 isn't. Because we have a coefficient of 1, we can use the FOIL method essentially. We're looking for factors that multiply to give us negative 35 and add up to give us a negative 2. We could have a negative 1 times 35, which add up to be 34. That's not the case. The next factor and only factor pair would be a negative 5 and a 7. When multiplied together, give us 35. And when we add these together, we end up with a positive 2, which means simply we'll reverse the signs on these factor pairs. So we will have x squared factoring into an x with a plus 5 and an x minus 7. And a quick check on that. When you multiply your first terms and your last terms, we should end up with our x squared and the negative 35, which we do, but also as equally important is to do the O and the I portion of the FOIL method. Here we have a negative 7, here we have a 5x, negative 7x, 5x do give us the negative 2x, so it factors correctly and gives us an equivalent expression to what we were started with. In this next trinomial, always looking for the greatest common factor. They're all even numbers, so let's factor out a 2. Factor is dividing, and whether mentally you do the division or whether you write your 2 underneath, that's totally up to you. Dividing by 2 isn't too difficult. Let's see what we end up with here. 4x squared divided by 2 leaves a 2x squared. 18x divided by 2 is 9x. And 10 divided by 2, a negative divided by a positive is negative, leaving us with a negative 5. Whenever you have a power higher than 1 on your variable, you should be at least concerned that this can be factored further. And because we have a coefficient here, we have two options, a coefficient other than 1, I guess I should say. We have a couple options. We can factor by grouping, or since this is a prime number and this is a prime number, we can do the guess and check method. To get our first term here from the FOIL method, we would have had to have had a 2x and an x. To get a negative 5, which is the result of our last terms multiplied together in our binomial, since 5 is prime, we only have one choice other than switching the signs around. The only way to get a 5 is with 1 and 5. So we can do a quick check here to see some possibilities, 2x and x, putting our minus 1 and our positive 5 that are possibilities here, and checking on our outside and our inside. Outside terms gives us a 10x, inside gives us a 9x, a negative 1, I'm moving too fast there, which when add together give us the 9x that we're looking for. So this is the correct factorization of this trinomial. If our signs had not been in agreement, if we'd come up with a negative 9, all we would have done is switch the signs. If this hadn't generated the middle term we were looking for, we could have switched our 5 and a 1 around for another possibility and perhaps the solution, but caught it on the first go. Whenever you factor out something, you need to always continue including that in your answer and replacing this trinomial we found when we have a 2x minus 1 and an x plus 5 multiplied together, that this is the factorization of this original trinomial. Here we have a couple other examples. This one has a 2-term, always looking for greatest common factor first. There is none other than 1. When it is a 2-term, we first should consider, is it a difference of squares? Well, the first term is a perfect square because x squared times x squared is x to the 4th power, and 16 is a perfect square. Square root of 16 is 4. It's a difference of squares, which means it factors into the square root of the first term, square root of the second term, 1 with a minus, and one of your binomials with a plus. A quick FOIL verifies that this is factored completely, but because we have a power higher than 1 on our variable, can we factor it further? We have a 2-term. Is this a difference of squares? The square root of x squared is x, because x times x is x squared, and 4 is a perfect square. So as it turns out, this binomial can be factored further because it also is a difference of squares. So in place of x squared minus 4, we will write the conjugate pair, which means first and second terms are the same in the binomial. The signs are different. So we end up with an x minus 2 times x plus 2. That's replacing this. The next binomial, yes, it has a power higher than 1 on our variable, but it is a sum of squares, and there is no way that we can factor that. It is a prime, but we also need to be sure we include that, because at any time, these, in this case, binomials need to multiply back together and be equivalent to the original polynomial. Here we have another polynomial that we're asked to factor. It's 2 terms, and let me back up. Greatest common factor is 1, so no greatest common factor to factor out. There's 2 terms. First thought should be, is it a difference of squares? Well, it's not a difference, so we don't even need to consider that. The other possibility is, when you have 2 terms, could it be a sum or difference of cubes? Well, difference of cubes is out, again because of the plus sign, but is this a perfect cube? Cube root of 27x to the 3rd is 3x, because if you take 3x times itself 3 times, it gives you 27x to the 3rd. Cube root of 1 is 1. 1 times 1 times 1. And then we're ready to factor this. The form for a sum of cubes is first term cube root, same sign, cube root of the second term, times square of the cube root, so 3x times 3x would be a 9x squared, opposite sign, so we'll put a minus, the product of the cube roots, so 3x times 1 will be our next term, and the last term is the square of the cube root. 1 squared, 1 times 1 is plus 1. This is the correct factorization for a sum of cubes. This trinomial, even though it does have a power higher than 1 on one of the terms, is not factorable. It's prime. And a good indication is if this binomial is to the first power, or the highest degree is 1, there is no way that this breaks down further. So we have factored it completely, and always it's a good idea to multiply these back together to check that you have factored it correctly.